Okay, IE 13. So what I've set is the next little section in our unit on parametric equations, and it is now using trig identities with parametric equations. So the trig identity stuff is what you're doing as blocks at the minute. Some of it will use some of the work that we've done last year on trig identities, and then some of them will use some of the stuff that you're doing at the minute with Miss Blocks, and I'm not entirely sure where you're up to. So what I've done is I've sent you this home as well, which is one of the Word documents that's got all the trig identities that you'll ever have to use, and I'll just load it and don't panic about that. So on the Word document you've got this example, which is the example in the notes. I'm on page 6 of the notes. So I'm going to go through this now, and then I've also set you a couple of questions underneath that which are very, very similar to this one, so you can go and have a go at those. Okay. So a curve has parametric equation x equals sine t plus 2 and y equals cos t minus 3 for all values of t, for all real values of t. Show that the Cartesian equation of the curve is x minus 2 all squared plus y plus 3 all squared equals 1. So what we have to think about here is, how do we rearrange this? Because usually we rearrange for t. Now if I wanted to get t on its own there, I've got an issue, because it means that I'd have to have sine to the minus 1 or arc sine or something. Now I don't want that at all. That isn't a nice way to be, a nice thing to have to rearrange with. So what I'm going to do, hopefully you can kind of spot, look, I've got something with x with a sine in, something with y with a cos in, and then this thing, if you look at it, something squared plus something squared equals 1. Now that should ring a bell for you to be using one of the Pythagorean identities, which is this one, which says sine squared, plus cos squared equals 1. So if I can figure out sine t on its own and figure out cos t on its own, then I can do whatever sine t squared is plus whatever cos t squared is, and I know that will always equal 1. Now we have to do it that way. I know you might think, well, I've got a sine and a cos, so could I not do something with tan? And if you think about that, all that I'll give you is you'll get an x, something in x divided by something with y, and that'll give you tan, and then even then you've still got like tan t within the equation, haven't you? So that's why we're not using that one. This one, when we use this in a sec, that will end up giving us no t's in the equation. Okay, so what we're going to do is we're going to rearrange this to get sine t on its own. So if we start off with x equals sine t plus 2, rearranging that, that's x minus 2 equals sine t. And this one, y equals cos t minus 3. Let's rearrange that to get cos t on its own. Well, that's going to be y plus 3 equals cos t. And then the identity is sine squared plus cos squared always equals 1. That's the identity that I'm going to use. So if I know that sine t is x minus 2, sine squared is x minus 2 squared. If I know that y plus 3 is cos, that gives me y plus 3 all squared, and I know from the identity that when I do those two things, that must equal 1. Right? So there we go. And in part B, hence sketch the curve. But hopefully you've recognised this is a circle, isn't it? That's x minus a all squared plus y minus b all squared equals 1. So it means that I've got a circle of centre 2 minus 3 with radius 1. So 2 minus 3 is going to be around about there. Draw a circle around it and just sort of show, it's an awful circle, but there we go, that you've got a radius of about 1. Okay, so you stop the video now and then have a go at the questions that I've asked you to do on the Word document underneath. There's a couple that are basically very, very similar to those. Rearrange to get sine, rearrange to get cos, and then use sine squared plus cos squared equals 1. Okay, they are from the booklet, and they are these questions that I've asked you to do. They're on page 204, questions 2 and 3 from the textbook, sorry, not the booklet, from the textbook. They are in this booklet as well further on, so you can use the solution bank if you want to. Okay, so pause the video and go and have a go with them. Right, the next one is trickier.